In episode 76 of Mobycast, Jon and Chris finish our series on encryption by digging into AWS's encryption services. Welcome to Mobycast, a weekly conversation about cloud-native development, AWS, and building distributed systems. Let's jump right in.
Welcome, Chris and Rich. It's another episode of Mobycast.
Hey.
Hey guys, good to be back.
Yeah, good to have you back. So Rich, what have you been up to lately?
So, looks like we're going to have our first full-time senior developer hire. It's going to be a promotion from within, but this will be the first actual full-time salaried employee. So I spent the weekend trying to figure out what that looked like, what the job role would look like, what the expectations would be.
Mobycast listener, I assume?
No, it's actually, it's the developer who's been with me the longest.
Great.
It's just ready for him to sort of take that full-time commitment. It's more or less me giving the commitment to him because he's already proven that he's, ready and willing. It was just really hard for me to come up with what that salary should be, commensurate with where he lives and also with what he's done. And I don't know, I spent probably 15 hours this weekend thinking through it, but it was one of the best exercises I've done because it also forced me to define all of the different roles that were sort of there but never defined in our company. So I think the outcome is that we'll have a growth plan for anyone who works with us moving forward, which is pretty sick.
Yeah, I've been really pleased with the WordPress work, especially the back-end parts and pieces that your team at Secret Stash has done. And I know that Alex, your new person, is a big part of that. So congratulations. That's great.
Yeah, it's scary because it's a huge commitment. But I feel like this is the risks you're supposed to take in entrepreneurship, right? So this is the right move, regardless of whether or not it's a risk.
Yeah. Yep. So how about you, Chris? What have you been up to?
Yeah, and so recently I kind of transitioned away from some of the day-to-day client work here at Kelsis. I'd been working on an account for basically since day one for about 2.5 years. And that took up a lot of my time, in fact, most of my time. And so recently kind of transitioned that to some other folks on the team. And that's freed me up to be working on some more strategic stuff for Kelsis. And part of that is having more time to be able to put more effort into Mobycast and thinking about ways that we can improve it, and from both a content perspective as well as from a production perspective. So we are looking to continually improve.
Yes, indeed. We haven't gotten around to the production stuff yet.
No.
So if you're like, wait, it's the same.
Yeah. We're putting together that plan of attack. Yeah. Don't hold us to the bar yet.
Right. But a new cool thing that we're going to try to do is we just want to hear from you. We want to hear from you, our listeners, a little bit more. And I think in order to hear from you, a big part of that is actually asking for it. I think you assume that we don't want to hear from you when we just blather on and talk about our own stuff, but we do want to hear from you. And so just today, I set up a new phone number. It's 844-818-0993. And you can just hit rewind as many times as you need to know what that is. And you can ask us questions there. And then also you can get in touch with us via #Mobycast and also at ask@mobycast.fm. All three of those I set up today to prove that we really do want to hear from you. And if we get some good questions, which I'm sure we will, then we'll start to take some time to answer those. And also today, I just asked our designer at Kelsis to put together a t-shirt design and sticker design for Mobycast. So there could be a good reason, if you know what I'm saying, to ask us some questions. Because our Mobycast art is pretty cool now. And I think you might want to wear it around.
It is. I may have to call that number and leave a question.
Yes. All right. So what are we going to talk about today, Chris?
Today, we're going to wrap up our multi-part series on encryption, and we've laid the framework, the foundation for just all the ins and outs of encryption and the various types, and definitely kind of going into pretty deeply symmetric encryption versus public key encryption and how that works in the real world with things like TLS and end-to-end encryption. So today, we're going to talk about encryption services available in AWS, since that is definitely one of our favorite cloud platforms, and just talk about how this rolls all into that.
That sounds great. Before we get in there, I was thinking about our last episode last week, and it came up over the weekend. Apple is kind of in some trouble because people are complaining that they've been recording Siri, things you say to Siri, and that you can't go and delete the things you say to Siri. Did you hear about this, Chris?
Yeah, I did. I mean, this kind of feels like it's a rolling issue throughout the whole. And I mean, everyone that has voice assistants, they're doing this, right? So whether it's Google, whether it's Amazon,
sure,
or Apple, right? They're it's all under the guise of like, this is like, we want to get better, right? So it's all about quality control.
Right. And I guess with Google and with Alexa, it's possible to go and say, hey, delete all my recordings. And with Siri, it's not possible to do that. And the reason is sort of surprising. It's because Apple was so careful to make sure that they couldn't that people were not associated with these recordings, that they made it impossible for themselves to go figure out which recordings are yours. So when you fire up Siri, a unique ID gets created, and then that ID is something that only your phone knows and Apple doesn't know. And that is what ties you to the Siri recordings that you've created. So then later, if Apple is like, if you say, well, I want to delete those recordings, Apple's like, I'm sorry, like, I don't know how to find them. There's no way with this. We don't have access to this ID that got created. It's different for every recording. It's gone, but it is not gone, if you know what I mean. And it just really reminded me of our end-to-end encryption conversation yesterday about liability and about kind of companies driving this and companies wanting to stay hands off. But in this case, I think the problem is that they didn't encrypt the recordings. They only anonymized them. And so that's not really anonymous, because you can still tell who a person is if you can hear their voice.
It's a good point. Yeah, I mean, I think, Apple kind of leads the way here with privacy and really kind of treating that as a first-class citizen on everything that they do. And so to anonymize the voice calls is a really good step in that direction. But as you point out, your voice is a signature, right? And you can, with just technology today, I mean, you can imagine it being possible to, if somehow you got a hold of like a slew of recordings of Siri, and then you run it through some other system using ML, and you can figure out like who this belongs to.
Right. If you're a famous actor and you say, hey, Siri, remind me about my meeting with Steven Spielberg later at 3, I think you might be able to figure out who it is and what they're doing.
Yeah. Although then it gets into like the funny, like, what if it's an impersonator?
Right. Okay. So let's get into how AWS works. I just thought that was a fun little side trip.
So, I mean, most of this, I think today, what we're going to focus on symmetric cryptography. And so, I mean, there are ways to do public key encryption with AWS, but it's a bit more, you need to do some heavy lifting yourself to make that happen. Out of the box, KMS, the key management service, is like one of the core AWS services that involves encryption, and that is symmetric encryption. So we're going to kind of keep symmetric encryption top of mind today. And just as a reminder, with symmetric encryption, you have that single key for encrypting and decrypting data. So it's very much an important secret. Both parties that are involved in that communication need to know that secret. So it's very important to protect it. And we've talked about in the past, in previous episodes, how you can protect this by encrypting it. To have now so you can use a master symmetric key, encrypt it to produce a subsequent key and use that one. But at some point, you're going to need a plain text key to exist, right? You can't keep encrypting and putting something inside the envelope at the end of the day. Like, you need to have a plain text key somewhere, right? So a big problem becomes like, well, what do you do with it? Where do you put that? And this is where, I mean, it's obviously a well-known problem. It's been around for a long time. So there's pretty rich solutions out there for this, and it's pretty mature as well. So a really common way of solving this is using an HSM, which is an acronym for Hardware Security Module. And what these things are, these are appliances. Think of it as a black box essentially, and its only purpose is to store these secrets and then provide some encryption services around that. And the intent is that the key goes in, but the plain text key never comes back out of it. Is a key part of the tenant here. So the only thing that would come back out of it would be an encrypted key, maybe, but never the decrypted, the plain text version of the key. And so you have these things are very much locked down, and they're tamper resistant. Some of them are designed that if they detect any kind of tampering, it just wipes itself. And so it just, all the data is gone, right? It's just like this message will self-destruct type thing, which is it definitely pretty interesting. And just goes to show how serious this stuff is and how seriously we need to treat these secrets. So HSMs
are we going to get into how they actually work and what they do? Because I kind of can't imagine a machine where it's got this plain text key in it and you can use it? Like if it's locked away in there, then how could I ever even use it if I can't get in there?
Well, there's two main things that these HSMs are doing. One is they're keeping these, track of these keys. And the other thing is they are providing encryption services as well. So yeah, if you put a key in there, you can never get it back, right? It's like kind of like a black hole or something like that. Then it's not too terribly useful. But so what you do is with that secret that's in there, you can now do encryption, decryption with it.
Okay.
Right. So it will also do those encryption services for you with that particular key.
Okay.
Yeah. And so there's really not much, to these HSMs. It literally is just an appliance. They're, again, very locked down for the most part. They have kind of like pin pads that are used to kind of give access to them. It's not like it's a web interface or anything like that, right? They're by design, they're very hard to work with, to update their firmware and whatnot. So it's just, it kind of, in a way, it feels more like, the technology from 20, 30 years ago when you had to go configure a router, type thing.
Okay.
Yeah. So HSMs are definitely a good place to store your secrets, your master key, if you will. And so there's definitely a few options there. So one would be, have your own HSM on-prem. And this is something that a lot of companies do. And this is the historical path that folks have gone down. Lots of pros here in that you control the device completely and you have control over all the authentication, authorization. It also is really familiar to auditors. So if you're having security audits done, like they've seen these things before and they know exactly what it is. And they're like, okay, yeah, check the box. You've got it. But, with that, there's also obviously a lot of cons too. So, you have all the things that go into making this work in a cloud native world are now your responsibility. So dealing with things like latency, availability, durability, scalability, that's all your responsibility. And then obviously definitely limited integration with all your cloud managed services and applications.
I guess I'm hearing you and I'm kind of like, okay, everything you say makes sense, but I still can't get my head around, so imagine in an on-prem situation, I can't get my head around kind of the flow of how one of these would be used. Like, okay, I've got keys in this HSM, it provides encryption services. So what am I doing? How am I using it? I've got some software. It's running on another machine. Obviously, it's not running on the HSM. It needs to encrypt the message. How is this connected to this HSM?
Mm-hmm. So one way would be, so say you have an application and like, let's just say it's our end-to-end. We want to do some kind of like end-to-end encryption or something like that. Let's just say for the sake of simplicity, that our client that's doing the client-side encryption is actually is running on one of our web servers inside AWS, and so it's a Python application, and so it's now, let's just say it says, okay, I need to send a message to this other user, so I'm going to go ahead and encrypt it. So and let's just say we're just using symmetric encryption again to kind of keep this simple. So I need to symmetrically encrypt this. We'll do it the right way with envelope encryption. So that means that we need to create a new symmetric key from a master key. So our master key is in that HSM, and let's just say that again, this is on-prem somewhere. We have our applications running in the cloud. So we're going to assume that we have the right connectivity between our on-prem and our cloud devices, right? So we've got something like Direct Connect or VPN or something like that, some ability to call into it. That HSM, it's got we've put some API on top of it so that we can call into it. And so now our app's going to say, well, I need to go and I'm going to create this new key, this data key, and then I need to encrypt it, right? So, and I'm going to encrypt it with the master key. Well, the master key exists in the HSM. So what it'll do is it'll create that data key and then it'll make that API call going from the cloud to on-prem to that HSM saying, here's the data, turn this into ciphertext and encrypt it for me, right? And then now my web app can go encrypt the actual contents of the message with the unencrypted version of that data key and then send it on its way. And then the reverse happens on the other side, right? So it's making that call to basically to do the encryption of the data key and the decryption of the data key via the HSM because that's using the master key. And then the bulk of the encryption, again, will be done with the data key that's produced from that.
Okay. I think that the new thing for us in this conversation is this concept of a master key. Because we've talked about how keys, for symmetric keys, they're so important to keep secret. And maybe, I guess what you're saying is a master key is a thing that you can use to create other keys that you can use or encrypt other keys.
It's really similar to what we've talked about previously with public key encryption and using that for the envelope encryption. So we had to have some way to securely share the secret amongst the two parties, right? Without them having to share that secret. So we're going to use public key encryption to do that. So this is kind of taking that same technique, but saying like, we're not going to use public key encryption. We're going to use symmetric encryption all around. And so it's going to be symmetric encryption for the secret, but the secret is now actually going to be centralized in that HSM instead of doing public key encryption.
So are you saying that both sides, so when I get this data key that you're talking about that I ask the HSM for, are you saying that both sides know the master key, that the HSM knows the master key to encrypt the data key and hand it over the wire, and then the side receiving the data key knows the master key to decrypt the data key and use it?
Yeah, both sides have the ability to call the HSM, right, and say encrypt and decrypt this thing. So they're both. So one side
have access to the master key, but they don't necessarily have the master key in plain text. They have access to the HSM.
Yeah, and that's the really important part of this. Like these HSMs, that master key, it goes in and it never comes back out clear text.
Okay. So basically having access to the HSM is a proxy for having access to the master key.
Yes.
Okay.
Yeah, you have access to that to say, HSM, use that key that you have internal to you to do these encrypt and decrypt operations.
And the encrypt and decrypt operations that you ask it to do are typically on keys. Like, I need a key, so make one for me and send it to me encrypted, and now decrypt it for me. Or make one for me, and then I'm gonna, then I'll ask you to decrypt it.
It depends on the use case. I mean, there's just a bunch of different options here and just ways to use it. I mean, some folks use HSMs to offload TLS. And so all the TLS encryption and decryption is handled via, basically the HSM. They're actually, some of them are really geared towards high throughput and can do things like on the order of like 300 megabits a second encryption, decryption, right? So
that was kind of back in the day and more specialized hardware there probably, right? Like we're doing encryption, so I'm going to get the special encryption computer. And now it's like, now the encryption computer is maybe more just about keeping that secret and less about like doing all the encryption for me at a super high throughput, super scalable way. Yeah.
Well, they probably still exist, and there's probably still there's still a very good use case for it. Part of it is like we're spoiled, right? Because we predominantly are in the cloud. We're using AWS, and they provide all this stuff, right? And they're taking advantage of it. So to us, it's like we don't need to worry about it. But if you're on-prem, like chances are these become like real concerns for you, and you need to solve it, right? Like just having something like Nginx do it, probably not going to scale. Like it's not going to scale nearly as well. And it's not going to be nearly as performant as a dedicated appliance.
Yeah, and I just have this thought, like, who knows how CloudFront really works? AWS CloudFront, that's their CDN. They could have a bunch of HSMs helping them out. We don't even know. Yeah.
Right.
Cool. Now I get it.
Yeah. So that'd be one option, is just get your own HSM, host it on-prem, right? And then you do all basically the heavy lifting around it. Another option would be to go with a cloud-based HSM. So AWS does have a product here. It's called Cloud HSM, where it's literally like you can provision an EC2, a VM in the cloud. You can provision an HSM in the cloud. And so some pros here, again, you control authentication, authorization, definitely have lower latency now to your apps in the cloud because it's all together in the same network. You get the great benefits of now someone else is managing the device for you at a kind of an operational level. So things like updating firmware, making sure that it's available, durable, scalable. And then, the other pro to this is, again, it looks familiar to your auditors, right? Because these are industry standard devices. There's an industry spec for this called FIPS 142, right? That kind of says like, this is what you need in order to be able to do the encryption and protect your secrets, like this is what's required for that. And if you comply to that, then you get this FIPS 142 compliance rating, right? So all this cloud HSM, it's FIPS 142, which is important. But the cons is again that limited integration with the cloud with other cloud managed services. So the cloud HSM, just like other HSMs, is going to be using kind of the cryptographic protocols for communicating with it. So it's not it's not a REST-based protocol per se. It's not it's not the it's more bespoke, right? It's very much a cryptographic protocol. So things like some of those protocols that are like PKCS 11, which is kind of a industry standard one, CNG, which is like it's a cryptographic protocol from Microsoft. But it's like encrypt, decrypt. It's how do you manage archive and the archive keys and things like that. So
and messages might have things like byte order and other not developer friendly things.
Yeah, it probably depends on the SDK that you use to implement that protocol. But yeah, I mean, it's definitely, I mean, it's its own thing, right? So that's the kind of the con to this, is that it's like you end up having to do a lot of application work on top of it in order to get this to work with whatever it is that you're doing.
Okay.
And then the third option, which we'll spend the rest of the time talking about, is using an HSM in the cloud that's managed that's a managed service for this. And so AWS has KMS, which is its key management service. And what this is again, it's HSM, it's in the cloud, but now it's a managed service completely, where you're not directly communicating with those HSMs. You're going through a translation layer. So they've built services on top of these HSMs to make it more friendly, to make it more cloud native, and then to do that deep integration with all the other cloud managed services that AWS provides. So the pros now are, again, you still control authentication, authorization, low latency. You don't have to worry at all about availability, durability, scalability. All that stuff's taken care of by someone else, by Amazon. But now you also get the deep integration with all the cloud managed services. So all the kind of the important services that you would expect to have encryption capabilities with, like S3 or Dynamo or EBS, all these integrate deeply with KMS, and it just works, right? So it just makes it so much very, very easy to go and build your application and build architectures utilizing these kinds of services. The big con to it, though, is that it's unfamiliar to auditors. So this is no longer just a pure FIPS 142 appliance, right? Like, this is some service that's built on top of that. It still uses the FIPS 142 devices. So KMS, at the end of the day, it is using HSMs to store the master keys and the secrets. But again, there's software that's built on top of that to kind of provide all this deep integration in this developer-friendly environment and just make it more cloud native.
Right. Yeah, I wonder, I guess you just, at that point, there is a certain amount of trust in AWS that has to happen, right? They wrote some software, and that's not the same as a hardware, a certified hardware device. So yeah. Software.
Yeah, and maybe just to point out some of the other major differences between Cloud HSM and KMS is that with Cloud HSM, you do complete management of all the encryption keys. It is single tenant access, which is, for some people, that might be really important, right? It means that no one else, no other customer gets access to that HSM. It is dedicated just to you. Mm-hmm. And it's also going to reside in your own VPC, right? So some really pretty major isolation benefits here. So there may be, some folks out there that are just running in a really tightly controlled environment, and they have strict requirements that they have to comply to. And Cloud HSM may be just like the only option for them in this, given that it's single tenant and it's inside their VPC and whatnot. KMS is, again, an AWS managed service, so it's not inside your VPC. It's outside of that, and obviously it's now multi-tenant. Your data is going to be with other customers as well inside that system.
Got it. Okay.
Hey, this is Rich with a quick interruption to announce 3 different ways you can ask Jon and Chris questions. First, dial into our toll-free voicemail at 844-818-0993. Second, shoot us an email at ask@mobycast.fm. And third, by including the hashtag Mobycast in a tweet. Okay, let's dive back in.
Still, it seems useful, especially if you're not operating in a highly regulated environment.
Yeah, I mean, so KMS is, so let's just talk about KMS now, because this is really, I mean, again, unless you have really tight requirements that kind of dictate otherwise, like KMS is definitely the go-to service, and definitely the easiest to use, the most integrated, the most benefits, and it's rock solid. They're doing billions of requests a day with KMS. It is just one of those fundamental core services of the cloud now that, I mean, I can't even imagine what would happen if like KMS goes down. Like, I mean, it's just everything would go down. But they're doing, I think, something on the order of like 10 billion requests a day going through the KMS system. That's a lot.
Yeah.
That's a lot of requests.
And those are like, KMS is typically the requests are like, just give me this key, right? We're not saying, or are we saying decrypt and encrypt?
Almost all those operations are encrypt, decrypt.
Okay.
Mm-hmm. Yeah. Because very rarely are you, I guess it depends on the use case and the application. Some applications are creating lots of data keys. Mm-hmm. They're just burning through them constantly, because it's just, like basically for every kind of like session or transaction, they're just going to create a new key, right? So, but even for those, it's like the keys themselves are being created by the application. They're then making the call to KMS to encrypt it with the master key. Mm-hmm. So they're probably not creating master keys too terribly often. It's really just I want to encrypt and I want to decrypt with the master key. And, quite a few services are using the data keys approach to do that. KMS does have limitation of you can directly encrypt data blocks up to 4 kilobytes, nothing bigger than that. So it really does kind of make you think, about like, okay, I'm going to really be using this for that envelope encryption style, right? Where I'm going to use my master key to go create data keys, and the data keys, the encryption that happens with them is outside of KMS.
Okay.
Right.
I guess that's kind of what I meant. And it's hard to say this, right? Like it's still getting the keys out of KMS is actually a decryption operation. Like give me this thing so I can use it to do encryption somewhere else, is actually telling KMS decrypt this thing for me. And the thing just happens to be a key. Yeah.
Yeah. It's just what you're decrypting is a data key.
Data key.
Right. It's not a key that's actually managed by the HSM itself. Mm-hmm, right? Those are the master keys are the ones that are managed by the HSM itself, and those will never leave that box. You cannot see that clear text coming out of it. You could say, I want to decrypt master key, right? Give it back to me. There's no such operation. It just doesn't exist. Got it. Right? So, and there's a special way for inserting those master keys, for creating those master keys and putting them into the HSM, right? That's a pretty important process. And we'll get into that a little bit as well.
Cool.
So KMS, the main functionality is that it allows you to generate and manage cryptographic keys. And then it is operating as, it's giving you crypto services, right? So again, the encrypt, the decrypt. It is using AES 256, which we talked about in the previous episode as well, and kind of going into some of the principle behind that with the confusion, diffusion, and the using that secret as what makes the algorithm work, and not the algorithm itself being the secret.
Right.
So we've talked a lot about customer master keys. So CMK, you'll typically see that as the acronym. And again, that is the building block. That's the hierarchy. And that's really what KMS is managing from a cryptographic key standpoint, are those master keys. And with those master keys, like I said, you can encrypt up to 4 kilobytes at a time. And if you need to encrypt data of a larger size, then that's really when you want to go create that data key. And then you're going to use that data key to do the encryption, decryption outside of KMS, not have KMS do the actual encryption, decryption.
So this may be the right time for this, because I was recently playing with this. This is one of those things where I'm getting a whole bunch of context on something that I've played with before. And I hope that our listeners are too, because knowing the deep details of this is not a requirement to be able to actually have some success using it, but it sure makes life better when you know what you're really doing. And so this is what I was doing. I was like, I've got this API key that I got from Slack, and that API key is a secret and I don't want it to go anywhere. And then, so because I don't want it to go anywhere, I don't want it to get out, I'm going to put it in AWS Secrets Manager. And that seemed like a fairly straightforward process. But as part of that process, I was required to create a KMS master key and tell Secrets Manager that it, kind of essentially hook Secrets Manager up with that KMS master key. And then after that was all done, then Secrets Manager was able to give me access, give my code access to that Slack secret API token that I had. And that process was a little murky. As I said, I was like, what is really happening here? And it was particularly murky when everything didn't work. And the reason that it didn't work is because some piece of my infrastructure needed direct access to KMS. And I was like, what? I didn't, I thought that KMS thing was totally separate, and I just set it up for Secrets Manager. Why isn't Secrets Manager? Why can't I just say, infrastructure here, have access to the secret and Secrets Manager? Why do I have to tell it about KMS? And now it's kind of making sense. I had to tell that piece of my application about KMS or give it access to KMS, because that's basically saying what we talked about at the beginning of the episode. Like, that part of my application needs to be able to access essentially the HSM, the key manager, in order to be able to get access to anything that's inside Secrets Manager. That the KMS is sort of the gate, the lock on the gate to everything in Secrets Manager.
Yeah, I mean, and again, you and me kind of started off that with this kind of premise that, like, you can kind of get by with not knowing how a lot of this stuff works and the difference of doing symmetric encryption or public key encryption or how KMS works. But by knowing it, it'll save your bacon and save, it's important to know how all this stuff works and really what it's doing under the covers, right? Mm-hmm. And so Secrets Manager, what is it doing, right? Of course, it's going to use KMS for how it does encryption and decryption and securely storing that. So it's absolutely going to go and create a data key to do that. And in order to create a data key, it needs access to a master key. And so that's what you need to tell it to do, right? That's what you're doing. You're saying, hey, go use this master key for the purpose of encrypting and decrypting, for creating data keys that need to be encrypted and decrypted, because those now have to be stored somewhere. And just, a big part of KMS, one of the great things of it is that you get really fine-grained access control over it as well, right? So you don't want it to be wide open, right? That anyone can use their master key to do encrypt, decrypt, right? Because then it's not really,
right. Yep.
And it's not so much of a secret anymore, right? If you just say anyone can call into KMS and say, this is the key I want you to use, go decrypt. Instead it's got to be, who has access to use that master key? Mm-hmm. Who has access to make calls to KMS, and what kind of calls can they make? So you have very fine-grained access control to all of this. And, by default, that's going to be pretty locked down. And so that's the other part that you ran into there too, is like, okay, what permissions need to be enabled in order for this all to happen? But if you kind of know how it works, at least, in principle, and how these things are working together with, Secrets Managers working with KMS, and, what's happening between a master key versus a data key, and where the encryption, decryption is happening, and identity access management and resource policies and all that kind of stuff. It all ties together, and you're understanding all that is going to make life a lot better. It's going to make things go smoother. It's going to make it much more secure, and it's going to, save you from a lot of just banging your head against the wall trying to figure out what's going on.
Right. That was really, really nice what you just said. But part of me hears you, part of what I just heard is maybe you sort of saying, that sounds a little fishy what you're doing. Like maybe this piece of your infrastructure didn't need access to KMS because KMS made a data key that could have been shared some other way. Did I hear that?
Probably. I mean, if you're using Secrets Manager, then whatever app you're using to store and retrieve that secret from Secrets Manager, it doesn't need direct access to KMS, but you need to delegate access to KMS to Secrets Manager for the key that you're using, right? Because it's going through that intermediary. It's not your end application that's going to be talking to KMS in that particular case.
Great. All right. So where do we go from here?
Maybe we can just really quickly talk about these master keys and how they get there's two main categories of them. So one is AWS managed. And so these kind of hands off, you don't really have to do anything. It's just, and these master keys are only used by that service. And a really good example of this is S3. So S3 has an option for doing server-side encryption, and one of the options is SSE KMS. And that's what this is. This is it's an AWS managed CMK. That CMK, that master key that's being created by S3 is only used by S3. You don't have to do anything special, right? It's just all managed for you and really don't have to think about it. But again, it's per service. So it's not very flexible. So the other main category is customer managed. And so this is kind of the more, almost always have to do this if you're going to do anything with KMS, beyond just the really basic use cases. And so for the customer managed keys, you basically have three different options for how to create those keys. Because a big part of this, like at the end of I think we talked about this in previous episodes. I mean, a key is really, at the end of the day, it's just a secret. It's just think of it as a password. And so it's pretty important to pick a good key, right? That's not going to be guessable. That's not going to be compromised. So when you create a key, you need to provide the cryptographic material for creating, which is essentially, it's, again, for lack of a better term, password. And so you have three options when you create these keys. One is you just let KMS do it for you. And so you don't really have to think about it. KMS has its own way of generating this stuff, its own, some of the industry standard random number generator algorithms for generating a sufficiently large random key. So you can do it that way. You can also import you can provide it yourself. So when you create a key and you want to provide the actual key, the cryptographic material, you first create basically an empty key saying, I'm going to give you the material later. And then in the second step, you now say, okay, I'm importing the cryptographic material that's been signed and it's been signed and go ahead and use this. And then a third option is AWS now actually has the ability to integrate Cloud HSM with KMS. So you can actually store your keys and have complete control over them in Cloud HSM and then tell KMS to use those, which is kind of like the best of both worlds for those folks that have those really high requirements for control over their secrets. This is a way to leverage some of those great additional benefits of KMS, that the layered functionality on top of it.
Interesting. Yeah.
Yeah. So, we've talked about just identity and access management with this. So that's a big part of KMS. That's a great feature. So you can use IAM policies and key resource policies to control access to these master keys. And so you can lock it down on, based on identities like users, groups, and roles. You can specify the kinds of operations that can happen on them. So really fine level of control over it. Full auditing support for this. So KMS integrates completely with CloudTrail. So every API call made to KMS is going to be logged into CloudTrail as long as you have CloudTrail enabled for your account. So you know exactly what operations are happening and by which identity. And maybe something else that's pretty important is just the recommendation for if you're going to do this at scale. KMS at scale is envelope encryption is a must here, right? And so we've talked about this, but it is a pretty core principle, and it's important to understand. It's like for your primary encryption, decryption, you're creating a new data key. That data key is what's done. Is what's used for the encryption, decryption, and that's happening outside of KMS. And you're really using KMS for protecting that data key. So you encrypt that data key with your master key, and then the encrypted data key resides alongside the encrypted data. And then that way, decryption just becomes reading the encrypted data key, making the KMS call to decrypt it to get the plain text key, data key. And then now you can do the decrypt operation, again, outside of KMS. And so that's how you get scale.
So I guess I'm still a little stuck on the example that I came up with earlier, Chris, because I was like, you know what? If I'm not getting this, then who is our audience getting this? Is the listeners understanding? So I took a look back to this code that I have that I wrote, and it's doing something really simple. So let me see if I can try to explain it, and maybe the listeners can come along with us on this quick journey where you correct my mistakes, and hopefully I'll understand if there was a mistake here. So there's some code that I wrote that goes and gets a secret out of Secrets Manager. And in order to do that, it's using the AWS Node SDK. So it's Node.js. And then in the Node SDK, you can create a new client for the Secrets Manager. So there's a Secrets Manager object, and you can say, hey, I want a new one of those. And then once you have a client for the Secrets Manager, and you tell it what region, in this case it was US East 1. And then once you have a client for the Secrets Manager, you can say, get secret value. And then you pass it a secret ID. And in this case, the ID that I had given the secret was Slack OAuth token. And then it'll actually go and get that Slack OAuth token. And you don't give it anything else. You don't, that's it. That's the code. There's not at least in the way I invoked it, I didn't pass it a data key. I didn't pass it anything that feels like the encryption part of this. I just asked directly for it. So that didn't work at first. And then later, in order to make it work, I had to go into my function and add this little, I had to go to the Lambda function that this thing is based on. So this is a Lambda function asking the Secrets Manager for this secret. So the Lambda function, I had to tell it, here's your AWS KMS key ARN. And I gave it a specific AWS KMS key ARN, which is this long string that's got an ID in it. I assume that ID represents a data key in KMS.
That's the master key.
So basically, I gave Lambda access to the master key, to a master key inside of KMS.
So you told Secrets Manager, this is the master key to use when creating your data key. And so then Secrets Manager has to have access to that CMK as well, right? Okay. So, but the only ARNs that you'll have, right, with KMS they are CMKs, right? It's the master keys.
Okay.
There's no, you can't have an ARN to a data key because just by definition of how data keys get what they are and how they get created. Right?
Sure, that makes sense. Because KMS is just managing master keys. That's what it does.
Yeah.
And so the secret is protected with a master key. Yes.
No, the secret's protected with the data key, right? But the data key is protected by the master key, and that's what you're telling it to do. So you're saying I'm going to go. I want you to keep the secret. Right. And you're going to tell this is the master key to use. And so it's going to say, okay, I'm going to go create a brand new data key, generate some random this is my symmetric key that I'm going to use for it. I'm now going to make the call to KMS to encrypt that key. Right. And so now I have an encrypted data key. Secrets Manager will then encrypt that secret with the data key and then alongside it store the encrypted data key. Right. Okay. So now when it needs to decrypt it, it just it says, okay, here is the encrypted data key. I need to ask KMS to decrypt it and get back the plain text data key. And then using that, I can now decrypt the data and give it back to you.
Okay. So then I guess I'm still wrapped around the axle of, does this seem like I did it in an insecure way by handing Lambda this ARN to a master key?
No, you have to. Right. I mean, that's just how Secrets Manager work. It's like the same thing like with just about any service that you want to do encryption. You're going to be telling it what master key to use.
Okay.
Right.
Now it's starting to make sense. So
because what you're doing is you're delegating it the ability it now has access to that key, right? To do these encrypt and decrypt operations. I mean, a good best practices for like building this out is that you don't have a single master key, right? Like if you just had one master key for your entire account and you're giving access to all these services to go use it, right? Well, now your blast radius is quite large, right? So you would break that up into having multiple master keys and break them out into different types of use cases.
So this does make sense. So anybody that needs access to the thing that's inside the secret needs access to that KMS master key.
Yes.
Okay.
Yeah. Cool. Which is how you lock it down, right?
Right. And so I guess the other thing that's sort of on my mind is like, doesn't this feel like almost an extra step? Because if KMS can encrypt and decrypt up to 4K bytes, couldn't I have just had to encrypt the Slack token itself instead of putting that in Secrets Manager?
Yeah, and so like there's, again, depends on your use case or whatnot. I mean, you can decide just to use KMS directly. So like we, as you know, in some of our apps, one of the ways that we manage secrets is those secrets are encrypted using KMS and stored in S3 as JSON objects. And for that, we're specifying a master key, and we're doing the encrypt decrypt on the actual JSON object itself. There's no data key that's being created there. It's just using the master key to do the encrypt decrypt.
And I bet that on the JavaScript side, it looks pretty much the same. It's like you probably use this, some SDK from AWS as well, and you create a client to KMS instead of creating a client to Secrets Manager, and you say to KMS, decrypt this.
Yep.
Yeah.
Yeah. And so when you encrypt, you have to tell it what CMK to use, but when you decrypt, you don't, because the CMK that with the ciphertext, part of its header includes ID to what CMK was used to encrypt it.
Mm-hmm, mm-hmm.
Right. So
then I guess some of the advantages of using Secrets Manager are just mostly organizational. Like, okay, I can associate these things together, and I can group them and do various things to kind of stay organized, as opposed to just having a ton of little data keys and a ton of random things that are encrypted with KMS.
Yeah, I mean, it's just use it for what it's for. So like, if you have like just secrets like credentials, passwords, connection strings, passphrases, I mean, whatever it may be, right? Like these bits and bobs of like highly confidential pieces of information, then something like Secrets Manager is a great thing to use, because it gives you standardized access to it, right? It's giving you an API versus like, the scheme that I talked about where you just use KMS directly. It's like, well, that kind of ends up, I mean, you have to build the API yourself essentially, right? And then you have to now have libraries in your code, right, to implement that and know like, okay, what bucket are they being placed into, and who has access to it, and how do you retrieve it? What's the format of it, right? And so,
but I guess this is the thing, though. Like, this is kind of like classic AWS in the sense of like, if I were building a secrets manager, like if I was making a company and we were going to make a secrets management product, I wouldn't make some separate like managed HSM thing that somebody has to know about and get access to in order to manage their secrets. I'd make it part of the management of secrets API. And that would be how it works, right? And not sort of surprise people by like, oh yeah, you got to know this other thing, and you got to like, that's like the way AWS has so forcefully just decoupled everything means that sometimes use cases are difficult to get your head around. Just like we had a hard time in this whole conversation, just kind of coming to terms with what I was even doing. It's like, oh God, it's because everything is so decoupled and everything has such good, strong barriers between them. You have to know a very sophisticated system, KMS, and Secrets Manager in order to just use Secrets Manager. Whereas somebody who's not used to AWS might think, oh, Secrets Manager, that should be easy. That's sort of intuitive when I say that word. And it's not intuitive.
Yeah, it's one of those, we brought this up quite a bit, where it's just like it's getting so big, right? The cloud is the new operating system, and it's just, there's so many services and there's so much functionality, there's so much surface area, there's so many things to think about when it comes to availability, scalability, security, and everything else. And trying to keep track of it all is just getting, it's getting more and more challenging, and that's not going to change, right? So it is a good model to have services that basically do one thing and one thing well, right? Like the microservices model. But as you get bigger, you start getting more and more integration between them, right? They're each becoming consumers of each other, and that's what's going on here. Like, it makes total sense. Like, if you're going to roll out Secrets Manager, it's going to leverage KMS to do the managing the encrypt decrypt of basically the master key, right? So. And you get all the great benefits that come with that, with like the IAM and the resource policies, resource control policies. But, the downside is like, now, like I said, you got to know both those things.
Yeah, totally. So we're past 45 minutes now, Chris. Did you want to wrap up with talking about incident response?
Yeah, I think just the other thing that's just kind of interesting to think about here is that, so how do you deal with like breaches, or what if your key did get, compromised somehow, or you want to delete your master key? The thing with encryption and decryption, right? If you don't have the key, you're not going to be able to decrypt the data, right? It's gone forever. So deleting or rotating a master key is a big deal. And so just one of the things that KMS does is they do enforce a waiting period. before a key is actually deleted. So you can say, I'm going to delete this master key. The minimum waiting period is going to be 7 days. So you have basically 7 days, right, to figure out like, oh no, like there's something here that is encrypted that I need to be able to decrypt, and it's now failing because the key is pending deletion. So it gives you a chance to restore that. But after that happens, and the key is deleted, it is gone forever, and anything that was encrypted with it will never be readable again.
So it's like quantum computing.
Yeah. Yeah. So just something definitely to think about. They do support rotation, and they handle basically what's happened is it's two keys. It's an active, and it's the new active one. The existing one goes inactive, but it's not deleted because it's used for the decrypt operations. But the new one's only is the one used for the encrypt operations, and that allows you to kind of gradually and then you can go and re-encrypt all your data using the new key. So just keep in mind, rotation is definitely, there's some tools there to help you, but it's a big deal, and I think they typically recommend you do that once a year. And then deleting of master keys, that's a very big deal, and you got to be really careful to make sure that you really don't need that key anymore. And by default, the minimum is going to be 7 days, and you can increase that up to a maximum of 30 days.
Interesting.
Yeah.
Yeah, it's like I guess. Yeah, I'm like, why bother deleting? Right? It's like they take up hardly any space. So yeah, I guess if you really want to make some data be impenetrable, then maybe that's when you delete a key. Like it's in the trash forever, for sure. It's really, really gone. Even if somebody were to find an old hard drive, they wouldn't be able to do anything with it, for sure. It's like the kind of the same as like shredding. Yeah,
and it's just kind of dealing with the case where like somehow the key has been compromised, someone has it, and so you just don't want that to be
get it out
anymore, right? Yeah.
Well, very cool. Thank you for sticking with us, listeners, and we'll talk to you again next week. Next week, if you've been bored with encryption, which I hope you haven't been, you have a treat because we won't be doing encryption anymore next week. Not sure exactly what we're going to do, but not encryption.
Yes.
All right. Talk to you later, Rich. Talk to you later, Chris.
All right. Thanks, guys.
See ya. Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us on and offline. This episode, along with show notes and other valuable resources, is available at mobycast.fm/76. If you have a specific question, we encourage you to call into our toll-free voicemail at 844-818-0993, shoot us an email at ask@mobycast.fm, or on Twitter with the hashtag Mobycast. Thank you, and we'll see you again next week.